So here we are taking again one more case related to what e power x into v. So v is nothing but a function of x. So in the RHS part you can observe that e power ax is there into a function of x is also there. So in order to find the solution y is equal to, it is always yc plus yp, where yc is given by what complementary function and yp is nothing but the particular integral. Now first we have to find yc, which is nothing but complementary function. For that, we are going to first form the auxiliary equation, and yc depends on what LHS part only, and pi, which is the particular integral, depends on the RHS as well as LHS part. So it is the same procedure we have to form. So it is already given in D form. Function of D is already given. So directly we can write the auxiliary equation, which is given by what? In place of D, you have to put it as m. So it will be m square minus 4m plus 3 is equal to 0, equated to 0 in order to form what? Auxiliary equation. Now we have to find the roots of m, and then we can find yc. So in order to find the roots of m, we can use this a quadratic equation. We can use calculator if it is allowed, otherwise quadratic formula is there, or the splitting of middle term, which comes under factorization method. So m square, so multiplying, so 1 into 3 is 3. So I should get multiplication, when multiplying two numbers I should get 3, adding I should get what? Minus 4. So the factors are only 1 and 3. So I can take here m square minus 3m minus 1m plus 3 is equal to 0. Grouping 2, it will be m common, m minus 3. Here also m minus 3 should be common. So outside minus 1 will be there. So m minus 3, m minus 3 common. So what is left out? M minus 1 is left out, equal to 0. Now from this multiplication factor is there. So m minus 3 is equal to 0 and m minus 1 is equal to 0. So from this we can say m is equal to plus 3 and m is equal to plus 1. So I got two factors of this thing, two roots of m. Now in order to form yc, always remember that yc m value, suppose if it is two different roots, so it comes under the category of real and distinct roots. Whenever real and distinct roots are there, so you can write that m value is equal to, suppose alpha and beta, two different roots. So yc can be written as c1 e power alpha x plus c2 e power beta x. Now, so yc value will become what for this particular equation? C1 e power alpha x means it will be 3x plus c2 e power beta x means it is 1x. I can write it directly x value x. Okay, so in place of alpha you have to put 3, beta you can put 1, vice versa is also right. So this is how we have to find the auxiliary, find the yc value. Now we have to go for the particular integral. So you have to write it in the form of what? 1 by f of d into e power whatever ax into the function of v, function of x, which is nothing but v, represented by v. Now 1 by f of d, what is the meaning of that? 1 by function of d means whatever is there inside the bracket you have to copy paste. So it will be d square minus 4d plus 3, then into e power ax, or whatever is there on the RHS side, just you have to write 3 power 2x into sine 3x, which is the function of x. Okay, after this what you have to do, the most important step is that after writing this we have to take e power ax, that means in this case is e power 2x, okay, outside, and change the to what? D plus 2. So what I have done here, we have to take outside e power 2x, okay, outside the operator, and change d to d plus 2. Why d plus 2 I am writing here? Because in this particular thing, e power ax form you have to observe, there a is there. So we have to change d to d plus a depending on this a. So e power 2x in the particular question here, we can see that it is 2. A value is 2. So that's why I have written here 2. Okay, it is based on only e power ax. Now we can change it. So yp value will become, now bring this e power 2x outside into 1 divided by d square will change into what? D plus 2 the whole square minus 4 into d plus 2 plus 3 into sine 3x. This is the function we have got. Now we have to simplify this thing. So e power 2x into 1 divided by d square plus 4d plus 4 minus expand the bracket minus 8 plus 3 into sine 3x. So yp value will become what? E power 2x into 1 divided by, simplify this thing, d square as it is, 4d minus 4d cancelled, 4 minus 8 plus 3, it will be minus 1 into sine 3x. This is a simplified version. Okay. Now we have to apply what? The sine 3x form. We have already studied that case where we are having k into cos ax form as well as k into sin ax form. So this is sin ax form. So for that, how to apply the formula? Let us try to understand that. So yp value will become what? E power 2x into. Now in this case, always remember you have to substitute d square value as minus a square. Now this a is different from that a because we are applying c e power 2x will be sitting outside, so we have to not bother about that thing after putting it outside. Now we have to bother about only sin ax. In that a term is there, a term here it is 3, so I have to substitute as minus 3 square, right? I have to substitute as minus 3 square. What is minus 3 square value? Minus 3 square value, so minus 3 square value is minus 9. See, minus 3 into 3 is minus 9. It is not minus 3 the whole square. Minus 3 the whole square is minus 3 into minus 3. It is not that. It is minus a square. That's why it is minus 9. Now to substitute in place of d square. So it will be 1 divided by, in place of d square, I'll substitute minus 9. Minus 1 into sine 3x as it is. Now here what will happen? E power 2x into 1 divided by minus 10 into sine 3x. So we are not getting any d value remaining. D value is not remaining. So since this will be the final answer. So you can just simplify and write it as yp is equal to 1 by minus 1 by 10 into e power 2x sine 3x. This is yp value. Now we have to combine and write the final answer. So y is equal to yc plus yp, or we can say complementary function plus particular integral, which is given as yc value already we know, e power x, c to e power 3x minus 1 by 10 e power 2x sine 3x. So this is the complete solution.